So the last piece of the experimental necessities is going to be random assignment, and random assignment is one of the more important ones that we have to deal with. Now the goal here is that by using random assignment, we are going to reduce systematic variation between the groups. So what does that mean? So when we randomly assign, what we're doing is we are randomly basically putting people into different levels of one of the study's design. So in doing so, what we're doing is we're reducing either biases that exist by the researcher themselves, or we are preventing there being some alternative explanation. This thing right here, this random assignment, is what actually gives experimentation its biggest advantage, and we'll talk about this in a second, but it's going to be high internal validity. So imagine a couple of examples. So let's say I had people come into my lab, and I was going to assess their physical strength. And in one condition, they were going to eat a lot of protein before they lifted weights. In another condition, they are going to fast, so they're not going to eat anything, and then they're going to lift weights. So let's say if a person came in and I looked them over, and I'm like, wow, you look really strong. You're going to be in the protein condition. You're going to go eat. Go over there. And then another person walks in like, wow, you're also really strong. Go in that other protein condition. So you guys are in the same group. And then someone walks in, they're just really frail looking. They're really skinny. They don't have a lot of muscle. I'm just like, oh, you're in the fasting group. You go to the group 2. By doing that now, you're creating a bias. You're creating a possible alternative explanation for your results. And if you find an effect, you don't know if it's because of what they ate or because of their body types that they had walking in. And so that creates a problem. However, I would like to think that most researchers aren't like that, where they're purposefully setting themselves up for success in terms of finding differences between groups. But another more important thing is that there are, when people come into the lab, they come with their own personality. And so if I'm measuring aggression, let's say, and I'm going to randomly assign people to be provoked or not, and then measure aggressive behavior later, I'm not going to be able to measure every aspect of the person's personality when they walk in. And so by random assignment, what I'm doing is I am randomly taking differences that make you different from your neighbor or different from your roommate. Whatever those differences are, I am randomly partitioning them out into the groups that they have. Now, it may be the case that random assignment fails, and for some reason we just have all extroverted people in group 1. But if that wasn't intended and that's just the way the cards fell, then you can be pretty sure that having all the extroverted people in one group, that is more or less just bad luck, if you will. Right? It's bad luck because what really should happen is that extroversion, in this example, should be randomly spread out between all the different levels of your independent variable. And that is what makes this thing good. So random assignment is kind of the key, in my opinion, to experimentation. So let's take something like this. Let's say we were doing that Penny and Ballard follow-up study, where if you recall, in this particular study, remember, we're going to have 3 different video games here, and we're going to have men and women play... Oops. That's too many. Let's say, okay, there's just... erase that. There you go. Let's do that. And we're going to have men and women play these 3 video games. The video game variable, this is a 3x2 design, first of all. The video game variable has 3 levels, and that is a randomly assigned variable. We are going to determine, before they even come in, what condition they're in randomly. However, can we randomly assign the second independent variable? We cannot. We can't flip a coin, just be like, oh, you're male today. Or another thing comes in, we flip a coin, oh, you're a female today. Like, it doesn't work that way. So just because a variable looks experimental like it does up here in this picture doesn't mean that it's experimental. So the video game is The sex of the participant is not, because you can't randomly assign that. So guess what? Can we make causal claims about sex differences? No. We can't because it violates random assignment. And it's not a manipulated independent variable. We have to manipulate it. All right. Now, how do we do this? Well, it's pretty easy to do. We can flip a coin. We can roll a dice. We can use a random number generator. There's a lot of different ways to do it. But the bottom line is it has to be random. Now, if you have all three of these conditions met, then you have an experiment. But experimentation also has its limitations. The first is it has low external validity. All right, now let's think about why that's the case. Remember, we defined external validity before as how generalizable it is. So if we have low external validity, that means that experiments aren't very generalizable. And this makes a little bit of sense. So let me give you an example. There was a study by an older study looking at memory by a researcher named Baddeley. And what he did is he randomly assigned people to learn a set of words on land or underwater in like a scuba outfit. And then, so that's the first independent variable. The second independent variable was they had to take a test either on land or underwater in the scuba gear. So first, what is the, first of all, let's focus on this. What type of study is it? It's an experiment. Why? Because we have a manipulated independent variable. We have two of them. Where they studied is the first. Where they took the test is the second. And we have a measured dependent variable. It was their scores on the test. And so that was measured. And then it was randomly assigned. Right? They were randomly assigned these four conditions. What type of design is it? It is a 2x2 design. All right? Can we make causal claims about any results that show up? Yes, we can, because it's an experiment. But here's the question for you. So what did the results show? Let's back that up. First of all, what the results showed was that if you studied on land, you scored better if you took the test on land. And if you studied underwater and you took the test underwater, you also did well. But if you switched them, so if you studied on land and took the test underwater, you didn't do as well. And he made the claim that this is state-dependent learning. Great. Good. It's a good experiment. My question to you is, how often in the real world, outside of the lab, are you going to study and take a test in scuba gear? You're not going to, right? You're not going to take a written test in scuba gear underwater. It's never going to happen. And when it doesn't happen, that in the real world, that means it just doesn't happen. Meaning, once again, we have low external validity. But guess what? With this limitation, it's an issue. Guess what a strength is? High internal validity. All right? By using random assignment, what we're doing is we are now confident that the IV is the thing causing the DV. So here's what people say to me all the time. Once again with my provocation work, they say, "Oh, I found this awesome main effect of provocation. Those who are provoked are more aggressive." People will come to me, well, what about sex of participant? Random assignment. What about how aggressive they are as a person? What about the personality? My response, random assignment. What about, maybe they just had a bad day when they came into the lab? You know what I say? Random assignment. Random assignment, random assignment, random assignment. Any possible alternative explanation that you can come up with that I did not personally manipulate or measure in my study, my response typically is, oh, that's a great area of future research, but we randomly assigned. Random assignment. That's what gives it high internal validity. So what's interesting is that when you're designing your study, you have this weird trade-off here, right? Between, do you use a correlation, which is cheap and effective, right? Or do I do an experiment? By the way, experiments take a lot of time. They're very costly. But the cost is worth it to me, where you have causal claims. But the trade-off is low versus high internal validity and external validity. As one goes up, the other goes down. As your external validity goes up, you become more correlational. And as you become more correlational, you lose causality. But if you want high internal validity, like experiments have, you lose some of that external validity. Because the real world outside, if you look out your window right now, you will see that the world is a multivariate place. Maybe out your window right now it's raining, and that puts you in a bad mood. Maybe the sun is shining and you feel good. Maybe you're just like, man, I really don't want to listen to this anymore. I want to go outside. That is going to influence you, right? That's going to influence you. But guess what? Random assignment. Random assignment. All right, the second limitation is ethical considerations. We've already talked about this enough. But basically, remember, I can't assess there are certain topics I cannot assess in the lab using random assignment. Like I can't randomly assign people to snort a lot of cocaine or to have sex or to, in my aggression research, I can't say like, oh, the person next door provoked you. Here's a knife. Have fun. I can't do that. All right, so there are ethical considerations. And finally, the question becomes, can we control for third variables? Remember, this is a major criticism of correlational research is that we can't, right? And it's easier to do in the lab because you're controlling for things, but we also have to understand that there's a lot of stuff going on here. So let me give you an example, all right, of third variables. When I was at Iowa State, in my PhD, there was a lab that was dealing with something called false confessions. False confessions are the idea that you didn't do anything wrong, but you sign a confession saying you did to get a worse sentence, like a worse, So they were looking at this thing, and apparently one of the female research assistants was attractive and wore a very low-cut shirt. All right, and what there was the worry is that because of the way she was dressed, that she would influence answers on these false confession kind of paradigms they were using more than someone who wasn't dressed like that. That is a third variable. That is a confounding variable that could be very bad. So, even though it's easier to control in the lab, it's not going to solve everything. But remember, random assignment. Oh, and by the way, these Iowa State people, what they did is they gave everybody lab coats to wear. So now what they said was that everyone has to wear a lab coat in order to make it equal for everybody. So that way and basically what they're saying was that no matter how this female research assistant was dressed, it won't matter because she was wearing a lab coat. And that's the way they dealt with these third variables. So, but it is important to know that they exist. But if you use random assignment, it should be able to deal with this. But this is also why, in experiments, we are very careful. Like my lab is huge. It has something like anywhere from 7 to 9 research assistants in it. And what we have to do is we use a set script. So we use a script where my research assistants, whenever they talk to participants, they have to say these words in these orders. And the reason they do that is to make sure that all participants get the same information at the same time in the same way. And that's going to be important for getting rid of these third variables that could come into play. So once again, let me just say that even though it's a limitation, it's going to be a limitation for every type of design, but it's less so than a correlation. And most of these things are fixable. And if they're not, then you just say the words random assignment and everything should get taken care of. All right. So that is the main deal with experiments. Remember, the word causal claims are going to be important here. This is going to, the last thing we need to talk about for this particular chapter is going to be something called complex designs, where we have 2 independent variables. So that'll be on the very next set of online lectures that I will post as soon as I have them done, probably after the weekend. So with that said, I will post them when I get them.